Okay, so during the last lecture we have been working on our data panel application, and I think we just added the listing of plugins. We have something changed something that what did we change here that it broke? More bug here that needs to be public. Wait, that's the wrong program. That's not the demo. There's a data panel. And once it started, we had the ability to add plugins from a list. Demo plugin, new plugin, and what we are still and this already the remove is not implemented. So let's add the demo plugin, and we were so far that it should be capable of drawing. So this is the next thing we need to add here, a mechanism to list the individual streams that there are in the plugin, so that they can be configured. Okay, so we have our data panel. In data panel, where is it? Here. So we have our timer. It runs periodically and can get individual thingies. Right, start makes it the start. It should be working. I think we started something last time and it's not quite completed. Let's see. So there's our demo plugin. Okay, now get samples. Let's put a breakpoint here. Add it again. See if you reach it when we start. Yeah, this works. It fails with invalid channel. Why? Because we get channel 0. I think in the last lecture this was already working, so we have broken something. Okay, I'll just start at channel 1. That's how we define the channels. And I think we added a test at the very end for the channel ID, and this is why it didn't quite work. Okay, suck. This seems broken still. I know why. Data panel. Yeah, because this now goes until count. It needs to be count plus 1 or equals. If this is how we define it. But then it is not compatible with this thingy. The simplest fix is just to will be just to define that the channel ID start at 0 instead of at 1. I'm not sure why we have changed this in our demo plugin to channel 1 be 1 not 0, but that complicates things, so we just define the channels to start at 0, and then we should have it. It doesn't work. Okay. So here we get this working. Okay. Well, we broke something. 'Cause last time we already had successful printing. Channels 1. Okay, so this should be done here. Then it should exit and then it should replot. This seems correct, but it doesn't plot anything, so there must be some issue with adding the curves. Plugin menu, update channels. So let's test if this works correctly. Add. Right, so we go here. Get channel count, which is 1, which is correct for a demo channel. We add at index 0 a curve with some color to our plot. Okay, and then if we go to timer event, once we start it, we should so we make an update. We get channel data, which are okay, size is 0, so we are not getting any data from our plugin. Let's put a breakpoint here and enter it again to see what might be the issue. Get an error here from get samples. Zack. Okay, so we are missing a break here, indicating that so in C++ the switches always fall through to the next case, and if we here return an error, then of course the thing will not work correctly. Yeah, now it's working, and it's now updating once per second. And what we will want to do is we will want to change this here to use proper timestamps, maybe, instead of just randomly incrementing the value. So let's go here. We start with this. Okay, so we even have the right time. So the only thing that is missing would here be to allow the thing to query data faster. So what we would want is to start a new thread inside our plugin, such that the thread will, with some sleep delay, generate the data realistically, and here the get function will be only responsible for retrieving the already generated data. So let's pin the thingy begin so that we can find it easily. Those will be even further, and then let's implement that. So we have already a start and the stop function for our plugin. We will be using this to start and stop the thread, the worker thread. So we have init somewhere. Yeah, let's just put it here. Zack. Okay. We need to have a handle for the thingy, so let's include Windows H. Oops. So if a thread already is something, then we will return an error that is already that it was already started, already running. And if we try to stop and it is not running, then we don't do anything. This will always return okay, because it just means there is nothing to do. For the thread to operate correctly, we will need a few helper thingies. So something that tells the thread to keep running, like full beun. And later we'll look into also setting events so that we can wait for the thread to finish. Okay, so start is here, so we start of course run true, then create thread, null comma null. Now we need write function prototype for our entry function. It's like this, zack. So it was nappy. This will be our thread's entry point. Parameter, then let's take this so that we can communicate data further. Creation flag 0, thread ID null, and what the thing returns is a handle value, but this might be if or invalid handle value. So it might indicate an error like this. In this case we set this to null. It should not return null, it should just return handle value, but just in case we add this check, and then we of course return some other error. Define plugin error. Startup failed. This will be -5. Could make the error message of course a bit more descriptive, but why bother? We'll also reset this to false. And of course if everything was fine, then we just return with true. And what this thing here does is quite simple. It just sets this to false and wait for a single object on our handle forever, and close a handle, close handle, and is equals null. So now we need our function here. We want to be able to actually we can make it quite simple. We add here a void run function, which will just be executed as the function's internal mechanism. And since it's on our object, it has access to everything, so here we only have to cast the parameter to our plugin pointer and call run on it, and we return 0. So we would have the ability to return some error code, which we could then, after we waited here, retrieve with a function that gives us the exit code, but for our purposes this is not interesting. So what we do here is just a loop while run, and then it does something until run is set to true. As soon as once run is set, it's no longer set to true, it will just break out and start and stop. So what we will also need is something to store the data that we want to give out. We could in principle but we will need to grow the data, so let's go with a vector. So we'll include here hash include vector std vector double. We can copy the names from here, so data samples and time samples, data samples and time samples. And what we will also need is some means of synchronizing access to these variables. And since we want to be as generic as possible, we could here actually use a synchronization object as provided by the STL library as well. So we don't need to use some Windows specific synchronization objects. Like a critical section, we could just directly use a mutex as std has. Mutex sample log, and with this we should be ready for operation. So each time we start the loop, we log. Although the recommended way of doing it is to std week log log oops, sample log. Why is it complaining? Your reference, I guess. So with more modern versions of C++, you would set it here. Then the templates would be able to automatically devise the right arguments from the provided arguments here. But since we set the default, or rather I didn't set anything and let it at the default, which is CUF13, which is already 9 years old, then here, no more, 11 years old, then here we always need to specify the arguments for our templates. And the way this unique log works is that it just logs, and when it goes out of scope, it automatically calls unlock on our sample. That is a more fail-safe approach, since we can then exit at any point in time inside the loop and will not leave the log locked permanently. So it's quite a neat convenience object. Right, and once we have this locked, we just append a new data point, pushback, and we just take some random value. You'll also need the time, but the time is in the time is in seconds, and we want this to be in milliseconds. So let's be smart about it. What we can do is we'll get time now, and then we also use a Windows function, get count 64. So get the count gives us the amount of milliseconds since the system was let's call it just so get the count gives us a 64-bit number, giving us the amount of milliseconds since the system started up. The older version, the 32-bit version, had the wraparound after 44 days, but the 64-bit version is long enough that the computer will not not exist long enough for it to wrap around. And what we simply will do now is we had the start time, and then we'll just add to the start time the amount of ticks that passed since the last time we have checked ticks. So we will here calculate the difference, or maybe rather 2 lines further down. Cool. Let's again get the count, and then time. Oops. Time samples. Punkt. Push back. We take now times 1000 plus tick count minus ticks. So this should give us the time, and of course this we should cast to oolong to be to ensure that nothing will overflow. And then of course once we're done with it, we sleep for, let's say, 10 milliseconds. before we do the next operation. And then here, so if we want to query channel 0, we should then just lock our lock again, so that we are safe. The lock will automatically unlock once we exit the scope here. And then since we need to change a few things, so we don't know the sample count yet, we don't know anything yet. So we just lock, then now we can set the sample count to point size. Okay, so this is correct. Then here we can actually use this sample data from E, and then time data, time samples from E, and then we just need to clear both for the next go. Clear and clear. So each time we allocate new data, this is always incremental, yes. So each time we allocate new data, we add them to our we add that current data to the newly allocated object, and then we clear what we had, and then the thing gets unlocked. So this should run correctly. And since it uses an own thread, so we should, for testing, add maybe a breakpoint here and there so that we can check if everything works as expected. Do our thing, then we start it. So this creates the thread and successfully starts. And the thread, as you see, gives us proper data. We only are updating once per second, since the last time we implemented it like this. We'll speed this up shortly. So here we see the stopping mechanism. Let's add a breakpoint here as well. So we that's wrong. It should be if it's not. Oops. If it's 0, so this will not work. But we wanted to restart anyway, so that we can change here our refresh rate from the 1 second back to 100 times per second. That should give us a very nice and fast behavior. So let's again add it and start. And now when it will be okay, something is now when it's running, it is surprisingly slow actually. I know why. We have a small bug. Here we are sleeping after we have locked, so it remains locked, so we cannot retrieve the data. We move the lock to the begin, or we could explicitly unlock. That would fix the issue as well. Add, done, run. Yeah. So this is now nice and fast and in real time. And when we stop it, then we will step here, reset to false, we wait. Here we exit the function. And then here we manage to go past the wait. We would have waited here forever if we would not have if it would not stop. I mean, the way it's made, it will stop unless there is a problem with the synchronization. We could change this here to add an actual timeout and then terminate the thread if the mechanism doesn't stop on its own. But since this is rather risky, since it leaves things in a undefined state, we will here stick to the infinite wait time, and it should be fine. Okay, so we have added now this functionality successfully, and the next thing what we will want to do is to add to our data panel, as I mentioned at the very beginning of the lecture, the ability to list all the channels that a plugin might have, and show them in the tree with the different loaded plugins. So when we add a plugin here, we want to see 1 channel, 2 channel, etc., etc. We can retrieve channel names from the plugins, as you recall. Here we have just some very simple placeholder function somewhere, get channel name, yeah, which just gives us demo channel as a result, which is not quite super interesting, but it of course is reasonable. We will later also upgrade the mechanism such as to implement the ability to specify a few parameters during plugin creation. In this case, the amount of channels, and then the channel names will be created dynamically. It will be then like the demo channel 1, demo channel 2, demo channel 3, and so on. Okay, so let's proceed with that. So we go to our data panel, CPP, we go to our update channels. So we will assume that the count of channels should not change without the update channels being triggered. So here we will just add a second. Actually, we already have the loop. We'll just add to this loop the mechanism to add channels to the tree. Is that reasonable? Not quite. And do it here. Nope. Let's change it. Let's change it slightly. So we have here our update channels, and we will not do that automatically on add plugin. We'll actually remove the function. Instead, we'll move all the functionality to the timer, so that we will not only gain the ability to update the channels in real time, but also the system will be more consistent, since here whenever we add a plugin, it will automatically add its channels as well. We of course will need to this seems good, because resetting channels, of course, that then we will need to re-add the channel each time, but we have to be smart about it. So we will need to extend this function to actually do also the channel removal for us. So let's see how far we can get with this design. Generally, making things on demand and not like redoing everything over and over is the recommended approach. And then the channel is already, the plugin is already gone. Do we keep a variable here? We keep the ID. Plugin channels, we keep the ID of the channel. It should be doable. Okay, so reset channel for now goes away. This we don't need, it's like redundant with the before. ID we already have. So just grab the channel data. And since this is then on demand, then this should be done each time we actually create an instance. We should not redo it over and over again. And the counter here, which is just for assigning colors, we will just put it here. So and we make it static, so that we are just cycling for the colors properly. Okay, so here we have our loop, which runs for every plugin we have, and if it doesn't find the plugin, that the plugin has already been allocated in our tree, it creates it, and then here now additionally it will also add all the channels to our channel list, and then it should also add the channels to the tree itself. So we could of course make this dynamic, so that we can so that new channels could appear, but I think this will complicate things too much. Let's keep it simple for now. So we will keep this as is. It each time just adds a channel, and then it needs to add the tree entry. So here, actually inside the loop, on our item, we can create a sub item. The sub item is equals new tree widget item. Set text. Set text, and the text will be where's our plugin interface? Plugin. get channel name from I, no, from I, and we need to specify the column, so set text name column, and then we should also specify some data to be on the safe side. Set data. In the name column, we'll just write the index. In principle, we could go by the order, but if that would got messed up for some reason, it is safer to save the right reference value qt inside our object. So we have that. Okay, so it will now create a new sub item, and we of course need to add the sub item to our previous item. So let's add it here, and child sub item, and now we need to think about the reset function. So and for the channels we need the channel data. Here we add as a key, use the data was different. So what we need here to reset properly is first we need the ID, which we can easily get from the items data. We have set the ID here as user as name user role. Stack to long, and once we have the ID, we can then remove it. So we will here grab our curve. Oops, not this one. Data. This one. So we'll grab our data, and then for the data we need to go for every channel that it has. Data punct channels, but this is luckily already a list, so we have here already all we need to clean up this thingy. We only need to remove it at the very end, and we could do it in two ways. We could either here get this as a copy, which would be probably the most easy way, using the take function. So if you would have inside the thing like more complex thingies, then it would be more recommended to maybe keep the reference and then explicitly remove it. But since we here only have a vector, which is a copy on a write type object, then just getting it here will not be very computation intensive, and then the take function already removes it from the plugin channels. And here if we delete the item, I think that should automatically delete all the child items. So let's try it out. So we add a plugin, and the name didn't work. For some reason the name failed. Also it wasn't expanded, so what we could do is if we add an item, if we add an item here, where's that top level item? Set expanded true. Then we need to debug why did we not manage to get the right name. Because it was not implemented apparently. No, wasn't it? Plugin C object should be. So we have this here in our DLL plugin interface. This thingy, something here failed, and this starts at 0. So let's put a breakpoint here and just observe it while it fails. And zack, so channel is 0. Oh, I know why, because I think we were inconsistent here. We should of course also say the channel starts at 0 as we did here. We added here a bunch of code at the end of the lecture because we were running out of time and didn't test it, so that of course is a bit an error-prone approach, but now we get a demo channel correctly. And if we want, we could add, for example, something indicating the color of the channel that it would have in the plot, or add mechanisms to change the channel's color, so that, for example, if we double click on it, then we open a color picker, and then we can change it. We could also add the option to rename a channel, but I think for now we will not be adding this this mechanism. I think the channel should be more hardware defined, and then we just only have the option to rename the, maybe add later an option to rename the plugin. Although renaming the channels in that view would not be that difficult, we would only need to move this here outside, but then we would need to add some mechanism which actually checks whether the channel already was added or not. So we basically would have to replicate this mechanism of checking whether channels exist, and if they don't, then only updating individual parts of this mechanism. For now, I think this is good enough. And right here, I think we also are setting a name of the channel for the legend, which we actually not show. But let's, since we already have the name, instead of channel just a plus something, let's actually go with using the actual plugin's name in the legend. Did we disable this somewhere? But we have the legend. But we forgot to connect it. We can quickly check in our other project how legends are connected with the plot they belong to. Here we have not connected it either. Interesting. Oh no, we did here. Plot legend, bottom. That should be working. So in our plugin demo, panel demo, we also should be seeing the legend being added, but somehow that didn't happen. As I mentioned earlier, the new version here of Qt is not quite as compatible with QWT, which we are using for the plots, as it maybe should be. So apparently, let's quickly try this demo again. There is that's the wrong demo. This demo. No, it doesn't want to build. Because it's missing the library. Just to quickly gauge the scale of the incompatibility, if we need, we will not be fixing the library. I think that would be too much work, but we might look for a quick workaround if that shows to be too annoying that it doesn't show the legend. A workaround would be, for example, to show the color of the channel in the tree in some. Okay, so here we have the legend. It's weird that it doesn't work in the other one. Yeah. Plugin demo, data panel. QWT plot. It should be working. We added it the same way, and it should. I don't see a reason why it would not work. We have a need to refresh something. I don't think so. Usually when we do replot, it should automatically replot. We can move this outside, but I don't think this will make a change. Yeah, it doesn't. But as soon as we press start, then it shows the channel name. So this is okay. Yeah, we don't need more. So now let's look into adding additional channels to our test plugin. So the idea is that we will be adding some parameters to the add plugin window. So when we here want to add something, that instead of just set name, you can set more things. Also set name should have a space. Set name. Here. And the parameters which we will be able to set here should be somehow retrieved from the plugin. So we will need to define some communication protocol, some API between the plugin and the its caller, which will allow it to give it a list of initial parameters, which might in fact be of different types. So that complicates things. In the Qt directly, there is a type called QVariant, which allows us to represent multiple different types, and then you can just check the type of this thing, and then you know what it is and how to handle it. STL would have its own variant type, but since we want our plugins to have maximal compatibility, then we will need to devise something of our own. So let's go to our interface. So we have here this my string. This is probably a good starting point. So let's go with class my variant. This will be again a abstract object as everything else. Since we need to be able to pass those around. And we will also need to think about how to pass a list of variants around. We could go with the simplest approach and just to pass a standard C array, which is which just has a counter variable as a second parameter, which tells us how many entries there are, or just one array and it just processes the entries until it finds a null, and then it assumes the array is over. And then we can just fill it with this variance. That would be one approach. Another approach would be to also implement some own array type, but I think that would complicate things at this level a bit too much, so we will go with the more simple approach. If we would want some sort of array, we could later always resort to adding to variant the ability to contain a whole list of own variants. So and here we should have somewhere in the implementation of my string. Yeah. So in this case we have one that uses std internally. So in principle with the variant we could try a similar approach to use a std variant, but I think that actually might be even too complicated. Let's go with a very simple approach. One thing I'm just wondering is, do we actually need a get version on this thingy? I don't think so, so let's quickly clean up our C string implementation. So for the string we will not want a version, because it's just a string, so it doesn't need that. And then let's see what else we want. So for our variant we'll of course want it to be public. It will need virtual let's say int get type. We need to define that, or we could actually go with an enum pass enum int types. Oops, types. One is 0 and int is 1. Double is 2. String is 3. Sure, we don't need to number them. The enum will do it for us automatically if we want to just increment by 1 each time. And I think for a very simple variant, an int and double and the string is all we will need. Basically, string can represent most things anyway, so we could actually also go with the option that we actually just use strings directly to pass them around, and that's it. But I think it's nice to see another custom type that will be helpful. So const just gives us a 0. Then we will want to have some sort of set value like we had here. Just that it will be always the same set value, just with different types. So int. We should have two ints, a signed int and an unsigned int. As int, uint, and let's say that they always will be 64-bit because why not? Set value int 64 e value and unsigned int u value. Then the same for the one for double d value, and for string we also have, so we have all the setas. And for get we'll just go with the same approach as we have it here with the string. Actually copy those, since internally the string will still be a probably a string, although we could change this later on. And of course those will they need to be virtual. So get but the name will be changed. Get string then get data, and here we'll just have a virtual int 64 get int 64. Could add value to the name. Get int 64. Yeah, it's fine. Const get uint 64 and a get double. Get double. This should be everything we need. I think we can retrieve the type, so we know what we have, and then we can retrieve the value based on the type, assuming the type is correct. It is a very simple approach, but it should have all the required functionality. And then we of course need an implementation of this thingy. So similarly as what we have done. Where is that? Here, as we did in the helper, we'll implement an own version of variant. My the name, of course, is now a bit annoying. It's called my simple variant. So of course I don't need the enum. We'll need the constructor and the destructor, and then of course we will need to have something to hold the values. This is obviously not the most elegant way, just to copy our string here, but I think for the first version this is not the worst of the ideas. Set value set value get data set. We of course need a release function here to be implemented as always, and we need then of course a type variable, so it will be an int m type is equals a none at the beginning. Then let's go with an unnamed union int 64 s int 64 small s int 64 int 64 and double so all those variables reside in the same memory space, meaning we can only use one of them and then we need to stick to it, which is quite fine with our approach. The string here resides separately. We could of course improve this by adding a pointer to this, but then if we would change the type later, that would cause confusion and we might end up with a memory leak. So for now, we'll just go here with a simple approach where we will just keep those things separately, although we need to change one thing here. Our set string, we need to of course set the type of our variant to be string, and this one as well. So the mechanism is kept quite simple. Just as when we assign something, then we set the type to whatever we have assigned last. And for the simple types, this works good enough. For other things, we will need to make the things more complicated, at least slightly more complicated. as int 64 int 64, then we just set the right variables with the value ratio e value is equals u value double is equals d value, and of course here the getters override suck that one s in 64. We could actually check the type to be on the safe side. So if type is not equals this, then return null. Here it's u. Those would be in principle convertible. With the double it's a bit more complicated, so for the double it's really useful to have a check. Okay, for the string right here there's also some check. This will be in order. So for the length, of course, uref is string. Oops. And for the data we'll just return null, indicating there is nothing in the string. Okay, so this will be our variant. That should already work reasonably well. Yeah. Okay. Yeah. Looks good. So we go back to our plugin. Oops. To our plugin. And we need to add a few more functions. Maybe here even before the init function. So something like void but it's constantly implemented, as we might remember from here. From the other case, we had already an implementation somewhere where we statically initialize something and then just return those values. Was this here? You know, plugin info. Actually, we don't need to add a function. We could just extend plugin info. That makes sense. So, what was that? The plugin info object demo plugin contains currently only version and a name, but we could add the whole list of things that we might want to initialize to this. So what we'll need is the information of a type. The type we could borrow from our variant, Yeah, so we will create a new structure as plugin param info. Here we will return a size t param count and a pointer param infos, because there can be more than one info. Here I'm missing a semicolon. So this thing will need a param name, so a parameter name, then a type, and with the type we will go with semi variant types type, but we will add additional types which are not available there. String. The idea is that we can also want to create a combo box where we can select something which then will mean we need to provide these values, but these values of the combo box will be passed as basically either a number, or like the index in the combo box, or as a string value, so which ID this thing has. And I think it's more robust if we use some string ID, because this will ensure that if we add parameters later on, old configurations will not get different strange bugs where things are shifted by one. So in principle it will be of type string, but we need to notify the system that it will be somehow limited, and we could do it with a separate type. I have a better idea. We will not add a type here. We will add the type. Basically, make it check if there are default values for the type, and if there are default values, then based on those default values, then show a combo box or not. So we have the param name, we have the type, then we will need another thingy, param values, which basically will tell us which values are permissible. And the idea here is that this will then just give us a list of values to populate the combo box with. And if this list is present, we show a combo box, and if this list is not present, so if this is null, then we just show a free text entry window where the user can enter whatever they want to. Another thing which would be nice would be the ability to make a combo box, make a checkbox where we can just enter basically 1 or 0, true or false, checked or not checked. But this would be then rather a integer or a unsigned integer of type. So we could either define like a magic value for the param values, which will indicate that this is a checkbox, or we could add an additional parameter here. I think we'll go with this magic number approach, because this demonstrates the use of such special values. So I will have a default login magic plugin magic checkbox. The thing is that this thing here, we might not want to actually use the pointer as a magic value, but something more robust. So we could make just a string which contains usually not valid values, backslash x1 02. So characters below 20 are not really printable, they're just, well, they're not characters, they're just control codes. So we will just write here a few of them, like 1, 2, 3. And if we encounter this, in quotation marks, string in our param values, then we know that that should be of type checkbox. Plus we can of course check if this thing is of type integer or unsigned integer, which would tell us that we want a checkbox. And also this brings me to another small improvement. I think we should really go with at least allowing implicit casting between sint and uint. So here we will just make it accept both. So this is more failsafe. If we, because usually for small values these are identical and it works quite okay. A double, there is no point in converting a double to an integer or vice versa like this. We could of course make these functions more intelligent so that they check which type is stored and then make the right conversion if needed. Actually, why not? That is not so difficult. So if this is double, then we just return m double, and this thing will, so the compiler will automatically invoke the right conversion. Although this here is wrong, this needs to be an end. Okay, and this needs to be an end. And so we make the conversion. We could of course add more conversions, like, because everything is more or less convertible to a string, but I think for now this will be too much, so we'll just keep the most common conversion. And of course with double we could in principle also convert from integers. Just we need to convert from the right one. So if this is this integer, then we go with uint, and if it's the sint variant, then we go with the sint. And the compiler chooses the right opcodes to convert between integers and doubles and vice versa for us, so we don't need to do it. And it will so what might of course happen here is that you lose precision, because the integer is a really precise 64-bit number, while the double, well, it's a floating point number, so obviously it cannot represent in the full range of values a integer completely true. But as long as we are handling smaller integers, the rounding errors should not be significant. We could add here and assert that it will notify us during in a debug build that something is not quite as it should, but for now we will not be doing that. We will keep this simple. Okay, so we have our variant. Now let's continue with our plugin infos. Plugin info. Where we had this? Zack. Here. Okay, so we have our plugin info. We have the name for the field. We have its type. We have its value. We could add a default value. Would that be reasonable to make it so complicated? Because if we add a default value, then we either would do it explicitly and add here a pointer to a variant type, or we would do it like a variant and just have different default values basically for the different types of type that we might encounter. I think since we want this to be a statically initialized thing, we should really go with the integer approach. What was it? Just make a union for the default values like we had before. Where is it? But since here we have just pointers, then we can actually use here use for the string default value default string, default double, default uint, and default sint. Okay. Right, and with default string, as mentioned, the idea is that if there is a default string, then it will be tokenized based on a predefined tokenization character, like for example a vertical pipe symbol, and then it will be used in a combo box. We could also have like a special case if there is a default value without a pipe character, that it then uses it to pre-populate a free input text box. Okay, we have to look into initializing this correctly now. So we will go to our demo plugin here, and let's see. So this. Then we have an array, and to make it simple, we'll just initialize the array first. Plugin parameters. As plugin here. Infos. Random size array equals, and then we'll be needing to initializing this thingy, and we want the count, so array size of param_info. Okay, and this thing gets initialized with entries like this. So let's see, what do we need to initialize it. So first thing would be the name for parameter, so let's call it channel count. Then we need the type. Type will be integer. Well, actually it's an unsigned integer because it cannot be negative. Now we need to initialize the union, which might be a bit not great. Because we can only initialize one of them, and I don't think this thing will be happy. So what we could do is, of course, we could give a name to this union, to the type, and then initialize it first, and then pass it in here. I think this is the most proper approach. So as value, just uDefault. Just call it uDefault. So param_info uDefault param1 param1 default. Let's bring this over to the same issue that let's try and keep it simple. So the default count for the channels will be 1, but this doesn't like it. Okay, we can make it a bit in a convoluted way. So param1 default get I'm sure there is a nicer way to do it. Oops, no, that's not string. We want the. Wait, what do we have? Only one as int. The other should be uint. We said that should be the unsigned int is equals 1, and then we return it. So when we use a more modern version of that should work. Too many initializer values. This thing needs a name. Let's move this to default value, and here just s. Oops. S and pointer string. Oops, that should have no comma. this should be a uint, therefore it uint. Good. Okay, this is nice enough. Let's see here. Right, this needs to be, should be fine. Change the order. Oh, we have first the count and then we have the parameters, so that couldn't have worked. Okay. Yeah, so we have our channel count as the one and only entry, but this is good enough, I think. So let's at the breakpoint somewhere we are getting our infos. So we have load plugins. Just create the factories, and the factory itself was responsible, I think, for loading all the data. Okay, now, so name, here we have the plugin info, so we will want to save the information that we have got about the different things that are permissible, so we could update this to just save the plugin info pointer instead of name and ID. Plugin info. We need to change those two functions slightly. We have this, I think, defined anyway, so that will be quick. So, no, sorry, ID needs to be ID is different. We have only name from this thing. So ID stays as is and only name gets changed. So basically that makes things a bit more straightforward. Just here we go with m plugin info, and of course here instead of plugin info we just assign to m plugin info, and to be on the safe side, if there was an error then this is null again. This also means we need to check here if this exists. So if this exists, then it is used, else we just return an empty string. And then of course the next thing, plugin factory, here we need to add a few more things. So virtual and param, get param count. Virtual get type, or first name, string, get name, type, and default. We will use the Qt's built-in variant, q variant, get default. Suck. So now we need to implement those four functions. Oh, we forgot a very important thing. This needs an index. Int e, index. Because we can have, of course, multiple parameters, meaning we need to address them, and count just tells us how many there are. That was also implemented here. Zack. We forgot here to use this to say that it's an override. We should always do this because this avoids mistakes, like when we later change something and think it was fine, but the changed the function prototype, then the things would be kind of disconnected, let's call it, and that would of course not be great. And just for correctness, let's move the bodies here into our plugin CPP, because they will not all be super trivial. So here Plugin from DLL plugin factory, zack. The override, of course, doesn't need to be specified in the function implementation. Zack. And I mean, here, of course, one could go with normal if you want to use more lines, but this is fine. I think we don't. We can have also one-liners in. We are missing here the double dot. Zack. And here and here and there. Okay, so parameter count. And here we will do it a bit differently. So if this does not exist, so if this doesn't exist, or index is greater than index is greater or equals parameter count punct param count. Actually, we could even make it simpler. We can just call this function, then we don't need to check if this thing exists first, but I think let's leave it like this. Return just an empty name. Here return my variant types none. Though we could here also switch to the Qt variant types. Maybe we should do it. That will be more foolproof. Why is this complaining? Because it's of course here we need to correct. So this would, for example, be already an example of. Wait, or was it a plugin? Plugin factory. That would, for example, be already an example of something that would break. If we would have changed it there to the qvariant type and forgot to change it in the top, then the functions would not behave correctly. In our case, this would only cause the compiler to not compile because the other one function is virtual and we have not overwritten it anywhere. But if you would have a function which has a body, then it wouldn't be overwritten and the compiler would not have caught it. Invalid. Right here, and else switch. So we will need to get our plugin type. So as plugin param info, let's just pair param info is equals plugin info param infos at index. Technically we should say that this is const so that we don't modify anything, and this needs. Is there a question? I think this is not a question. I will just turn the user's voice off. Param info, switch param info type. Oh, we don't want this to have an m prefix, just type. We could give it a e type prefix. Okay. Switch case. Variant type S64 Ton qvariant int no long. So Qt uses determination long for a 64-bit integer. Double. It's just double. And string is string. String is. That will need improvement, but for now it's fine. And the default case is just invalid. So if we would get something we don't know what it is, then we just say this is invalid. Default parameters we have here. We will want to convert it to a Q variant, as a to a C variant, Q variant, yeah. So we get the thing, we get the type, we have here our types, and then just the conversion. So return a Q variant from param info default value punct, that was a sin64. Actually, we don't even need the brackets, we can just keep it like this. Win64 double punct double, and here that will be slightly more complicated. It will be Q string from char array punct p string, and if none of them hits, just an empty variant. Also, we need to add the check from the top as well for the index, so that we're on the safe side. Okay. Good. So this will allow us to read all the relevant things. So let's now create our dialog, which will be able to allow us to change those parameters. We will later also add functions to set and get those parameters, so that we might change them later on, not just during creation. That would be, I think, a good improvement. So let's go to I fixed it. Where we had this. So we have here our add plugin. Let's see, we have as a main layout a vertical box. That might not be good enough, so let's go with a Q form layout. That will be more on the lines of what we need. Q form layout, set layout, set widget, and now when we add a widget, set widget, we can specify a row and a role. Add widget, add widget remains the simple thing, but we will here now use set widget. We also need to count rows, so int row is 0 for start. So set widget and row plus plus, since we don't add anything else in the row, and then we need a role. Qt for Q form layout, and we have field role, label role, and we have spanning role. So a form basically is something where you are entering values, and the standard Qt form layout is on the left hand side you have labels, and on the right hand side you have the fields where you enter the values for the labels. And these two roles can be here differentiated with a label row and label role and field role. And the spanning role is if you want the widget to be in both windows. So basically you merge both columns into one large column. It's in principle a simplified form of a grid layout, but for our use case I think this is ideal. And if we do it like this, comma, like this, then let's not plus this just now. Here, this will be the field role. Field role, and then we plus plus. Or we could also make both as spanning roles, and then that would also be an option. Maybe we should do this. That will demonstrate both ways. Nice, I think. So row plus plus, this get plus plus, and this both will be spanning. So we want kind of have more space for the plugin selection, and then for the name, And what we will then need here will be to load. Actually, we will load once a plugin has been selected, the additional things. So we have here this on plugin, which is triggered once it's selected. It sets the default name, and then it will need to reset the a portion of the layout. So layout row count, that is one we need, and layout remove row. So for int e equals we started 2 because so 0 and 1 we always keep, started 2, comma e is less than count e plus plus, and then oops, it should be a semicolon. Remove row I. So each time we select a plugin, we remove everything and recreate the bottom portion of our form. So we start with actually we could make this extra fancy. We start with row let's not make it fancy, just row 2. Keep it simple. For int e, actually we could use e directly. Let's do this. E is equals 0, comma e is less than plugin. Wait. We actually need to get the plugin data, so plugin factories gives us a should pointer to a plugin factory. Plugin is equals plugin factories value, and this wants a key, and the key will be the ID, if I recall correctly. Plugin context, and I think the ID was encoded in data, current data to string, and this might be null, so if this is nothing, then return, but if it is something, then we can work with it. Get parameter count e plus plus. Okay, now we copy maybe this. Row will be I plus 2 always. Label role plugin. The text will not be subject to translation. Get param name from I. And now we need to add here the right type of field depending on the type. So again, we will have a switch which will switch based on the type. Get param type from E. Okay, skew variant long, just long. Then long, then double, then string. I have an idea for an improvement, so let's quickly improve it. Where's interface? Interface. So here somewhere. Plugin. This is not the right interface. It's here. We have defined types here. Starting at int, we will add a type boolean, which will basically be a just an integer, but the usage of this type tells the thing that we want a checkbox and not a entry field. But with set value we could just then stick to getting one of the integer values, which also means that here in the helper where it's actually implemented, we also need to be here tolerant towards Boolean types. Loop and return them correctly as well. Type Boolean, and then of course you would also want a setter for that. Set value, p-value, oops, Boolean. We are missing the thing in the base class here. It will need a getter, so get Boolean. And of course if we don't add it now here it will complain. Zack. And this time not for doubles. We just tolerate each of the ints. I mean in principle we could have an own Boolean here as well. Why not? Since we don't waste memory, it's fine to add it here. Get Boolean in here. It's like okay. Good. Our standard nomenclature was that the first valid one is the first. And it should be if it's not this and not this and not that, meaning this is bugged. Right. Okay, so if it's none of the above, it's 0, else we return it here. We have differently. Okay, so this is an improvement indeed. Let's look to our interface. We'll here add a Boolean bool as well. Nice. Save all. Plugin right here. No. Data panel here somewhere. And Zack. We are missing something. In the conversions place where we are doing the conversions here. Bool. Bool. And here. Punkt. Bool. Nice. Okay. So this is it. Set name. Do we remove set name or is name? We don't have name. Then we just need to use the get name function. Because we removed the name variable before in favor of just getting the data directly from the cached infrastructure. This is our window. Okay, so we have now the types that we want. We already have set the label. We need to store them somewhere, so we'll add here a helper qmap or as a list qlist qwidget pam widgets. So this will need to be cleared of course here as well. Yeah. Oops. So the string case we already know how to do because we already did it here. We just need a line edit. Stern per edit, which is append line edit, and then we copy this line here. field role, line edit, but it's again I+2. Asterisk is missing here. We want to collect the pointers. Right, and here we would have the special case with the combo box. But for now, let's just make it a to-do. Special case combo box. Double. And let's go with the line edits. So this can also be a line edit. Or we could use a Q. Was it Q? Spin box. It's like a line edit where you can use the up and down arrow button to set and to set new values. That is quite nice. So right, and we need to set a value. Set value. Plugin get param default at e to int. Then we replicate this just with to uint. Does actually take uncent longs? It doesn't. The normal spin box only operates with 32-bit numbers. So for now, let's leave it as is. For the double, we will just go with a normal line edit. We could add a filter to the line edit that allows only numbers to be entered. This is also an approach. And for here, we just wait, that is not good. So int, yeah, right line, but we still want to set here the value. Set text q string number from plugin e to double right, and here we want the q checkbox, new widget, new checkbox, set checked, set checked to boolean. That is a bit not great, because with the checkbox we might want a different behavior with regard to this. So if type is not a boolean, then we add a label. But if this is a label, then this thing takes the parameter name instead and displays on the other end of the thingy. Okay, let's test if this works so far before we proceed. Okay, that is interesting. They want us to work differently. Okay, then why not? Qt meta type. No, but this is not the right thing. Why? Okay, let's just go with integer. That will not complain about it. Apparently people use this in some use case where Qt wanted to stop that use case, so they changed it, but like this it should also is this enum class? This is I don't want to change everything, just let me use it the way I want it. Hmm. That is annoying. In the past this worked just fine, but they changed something to prevent people from doing exactly this thing. Yeah, but meta type that will not be. I don't think that we have just seen that the meta type. Although here I guess they implement everything from the other one. Okay, so let's just fine. Let's just stick with what they want us to use. This is of course slightly annoying. Zack, zack, zack. This will throw. I think we used it somewhere else as well. Some errors. Yeah, here. We forgot also to fix those. Zack. Is there no string? It's now called QString. Unknown type. Okay. I think it's not the last thing we'll see this. Yeah. Here we use this as well. Boolean. Boolean. Zack. Oops. Zack. Zack. Okay. That should be everything. Almost. This was renamed to QString. Okay, so add. Looks like a crash. Because we don't have plugin. No, we have plugin. Why wouldn't it work then? Was our plugin not rebuilt? This is a plugin filter that should be correct. Let's rebuild the plugin was built. So let's put a breakpoint here and observe what is not working. So we got the type. Okay, it says it's type 5. We should have a plugin object. Zack. We forgot to return the name. That obviously explains why it crashed. QString from char array. Plugin name. Quick fix and a minor issue. Okay. Something's not quite right with our layout. Let's see. So we have our layout here. Let's comment this out for a second to see if we are resetting something incorrectly or if the problem is so it seems we are resetting something incorrectly. If e is less than row count, apparently this does not work as we wanted. Let's see what it will try to do. Continue, add. Okay, so apparently we got a larger value than 2 in our row. So row count, although we have only oh no, we have 3 rows. We added here a third row, that's why it's failing. We should make this somehow fail safe because we already failed once. We'll make this m row a global variable and we call it rows. Because when it's global, then whenever we change it, because here for example we also used it quite a few times, just +2, which is extremely error prone. So let's go with plus rows. Okay. Zack, zack. something didn't work out because it kind of broke the layout still. Let's see if we still try to remove rows. We shouldn't. But we still do. We have rows 3 and this returned a different value than 3. Let's see how much it returned. Int test equals row count. Let's run it. It says we have 4 rows. Why do we have 4? Oh, because we added here buttons. That's a 4th row. Of course, this we don't want. We want to save the last row. So row count -1. The last row with the buttons should always be preserved. We need the buttons. And this, of course, should also be like added the correct way, although I don't think this will make a difference. I think the problem is something else. So row count -1 remove. So at least we should not try this anymore. Now we are overwriting the buttons. Can we use insert widget? Insert row. This is better. But okay, row. A label. This one's already both. This is not great either. I think the simplest fix for this problem will be to just have 2 layouts in our design. One which just holds the form and the other one which is a. So we replace this to be the form layout, and it will be Q, V, box. This will be reverted to just the V box layout. We need a widget for that. Q. Then pair form widget. We could have made it work the other way around, but that would be a bit more convoluted, so I think it's for demonstration purposes more reasonable to just use a more reasonable approach. File box layout. Q file box layout. Set content margins 0. Form layout and form widget. New Q widget. New Q form layout. Wait, one is layout, the other is widget. Layout is the widget as parent. Here we replace this. 1, 2, 3, 4. The last one stays as it was. This we copy. Okay. Oops, that's a major oversight. Zack. Okay. Let's try again. This thing is still broken. The buttons now work fine, but we are not removing anything, so this is correct. Let's add a return here. E plus rows is Okay, so if we don't add anything, it is fine. Did we plus plus on the last row add? Oops. Plus plus. That should be correct. Label field. Oh, I see. We have a major other problem. We forgot the break. We forgot all the breaks. That's of course annoying. So it might have actually worked with the few fixes we added to the form layout, but now since we already changed it, let's keep it changed, and in this spin box we can set values like this. But of course it will not create two channels because we have not yet implemented the functionality for it. So we will need now a way to retrieve those information. So we will add what will we add? We should improve this here. Stoked as param. Although we can retrieve the type at any point in time, so it's not so necessary. Let's keep it simple. We have here this like get new name, or rather it should be just called get name, and we'll make a Q variant get param int index. Yeah. Actually, we could use get factory here directly instead of doing it by hand. And we need this with get param as well for the type, but only for the type. So we could have kept this simpler, but for now let's do it like this. Zack. Of course this doesn't need caching here anymore. So let's just clear out the thing. And the to-do we will leave because this will also apply here. Q with get abstract with get is equals widgets at I. So we have the widget, then here Q checkbox, then equals Q object cast checkbox. So that's the safe way. This can always end up being null. So if this is null, then return Q variant, which gives us an invalid variant. And if it's fine, then we return is checked. Then here we had a Q spin box per spin box. If there is no spin box, then variant else value. But we need to cast this to 64-bit Q in 64. That's just sint. Oh wait, wrong way around. This one is int. This one is unit, and this one is int. Table is also oops. Table is also simple. Q line edit, Q line edit pen, P line edit, oops. double, and it will be a double. Text to double. Oops, to double. And string is just the text. Okay. And then we need, of course, a default case. Wait, that's not quite right. We don't need a loop. We are retrieving them one by one. Or the default we can make here. Oops. Small q1 and but we will need a list, or let's do differently. Q variant list get params. Then we just need to call it once. That's an improvement, but this means we would have needed the loop. So let's return it quickly. Q variant list params and no index. The rest remains, and then of course this whole thing will not do returns or anything. We need to push to the list. List. So here we have punct append and break, and of course not append. So let's change it like this on success. Yeah, okay. This is the same here. Oops. Here it's similar enough. Text to double, and here's just text. Break needs to stay. And in the default case, we just push an invalid variant. Append q. Okay. Good. So this way we get the list. Going to get a new name somewhere. Okay. Probably just yeah, here. As we change this to just get name. So we have plugin. We make a new plugin. We set its name. So the make should either get the parameters, or we will set the parameters with an dedicated call. Let's do the second one. That is, I think, more elegant. Set params. Get params. So we of course need to add this set params function now to our plugin. Virtual boolean. It will return true or false depending whether it's a success or an error. We could also go with plugin status. Let's go with this. Set params const q variant list reference params. Then we will want to have a get params, so it can also get the data. But this is our plugin interface, so no, that should be fine. That should be fine. We have our plugin, we have our two params. Those things need to be always implemented, so they are null. Okay. Set params, get params. Okay, with demo plugin and with test plugin, we will need to implement this somehow. We will not spend much time on adding things. This should be fine. Sorry, this is different. This just returns the queue-variant list. Demo plugin here. Okay, but then we need our more important DLL plugin, which we'll actually need to have. Did we this one? Set name, that name. Override. Zack. The get param could have been a const. It should have been a const, so let's quickly fix this. Here we don't care. Const and override, of course, to be on the safe side. This one but here, right here. Const override, okay. Plugin cpp. So I initialize here init. Plugin get name, set name didn't have anything. It will be directly under init. Okay, so this is the right place. Okay, we should speed up so that we actually finish adding this, because we will need that working to be able to give you some homework. Right, so set params, we have the list of the params, so on the instance we will just call set params, but we need to have a list, so queue-variant, or let's go with std, std variant vector. It's my simple variant, params, set resize to params.count. This thing will get params.count. There's a bug. There is a bug which we need to fix. Params count, because this is not a point, so this will be a vector of pointers that we can pass them properly, and this will be just a vector of, to be more correct, vector of param pointers, and we'll make a second array of actual objects. My or per params, pointer params, and just params, pointer params, pointer params, and here now we will need to set them as we go through this thing. Sure, we don't need to even resize it. This will find this for each const auto reference param, comma params. Wait, we already have params. The typo, so let's call this params by value v params. So v params punct pushback. Let's resize them. That will be nicer. Oops. Resize. Size is per params punkt pushback reference auf wie params set I. No, we don't have any. Then we need to change this. And e is less than size e plus. Oops. So then we have our e that goes push back, and this will be then this we'll need to set. That will be a to do. And then okay, so things are getting complicated quick. I don't think we will be able to do this in time. So what we need to do now is to add here on the factory, or just somewhere globally, a static function which converts a single parameter from the variant version to the non-variant to the from the my variant version to the q variant version, and vice versa, and then use it to populate. Use it to populate here our not here. What was it? Here our array, so that we can then pass the things over. And getting parameters would be kind of similar. I think the plugin has does it has an instance of the factory? No, it has only an instance of the instance, so that will also need to be improved. I think since we are running out of time, we will not be finishing this implementation. I just bring it to a state where it builds without bugs. And that is correct. It must return a value. And then we will continue in the next lecture. We are missing something here as well in our simple variant. What are we missing here? What have we added here that is missing there? Set value pool. It must be something we omitted. Abstract object has release and nothing else. We forgot to release it. Simple. That has the release. Okay, we should make type as override. That will be it. Get type is const. Get type. Oops, that is just a typo. Override. So the virtuals here can be removed. We have the overrides. Let's see what it complains. It complains that we have not initialized the variable, which is kind of correct. So let's initialize this. But this is not the reason for the compiler error. It should tell us which get type const is abstract. It is not. Int get type const. Wait, oh, I forgot here to make a return type. Haha. That was very careless. Right, and this needs to return a value. For now, let's just say return login. Okay. Oops. Okay. Good. And let's just add this set and get params to our interface. There where we have the init and the other thingies. Init. This will of course be a bit more old school. So set params is my variant asterisk params and int size t param count and get params, but this is const and this is not const. So get params will require to provide to it the right amount of variants in a list to be filled in. It will not try on its own to create them, since our implementation of my variant is only used currently inside the main application. We could of course let this create a list, and then if we do it like this, we would either need to use this malloc and free which we have passed to it, or we would need to have like a cleanup params or something function. So for our application it is most elegant to just expect it to have this list given to it, and then we of course will need this in the right places. So this is here and there, and here and then there, right? This is our abstract interface, and our demo plugin is missing this thingy. Right, get can be const, which will here of course complain because this is not const here. We'll need to add const there. Okay. And now of course the implementation of those things. So here we want the channel count. Are we actually using sample count for something? I don't think so. I just got rid of it. And just start with default value of 1. Reset sample count, but we were not using sample count anymore anyway, so this can go. We didn't have an init, did we? Yeah, init just does not do anything, so the next thing will be here. And here now, instead of channel count, will be channel count. That will need some additional changes. We have just 9 more minutes left, so let's see. This will be different, so it will just a okay, channel name, let's get rid of that. And here let's go with a std. What's the simplest, the most elegant thing? Std with string ch name is equals channel space std to to the string from channel, and let's give them like number. So let's go with let's just go with number, and then we just return this. So set value like this, but we need to make a check if channel is greater than channel count, then we return null pointer. Actually, if it's greater, if it's greater or equal, then return null pointer, then this, and then that. Okay. Reset is just plugin. Okay. Function is function. We will need to change the whole thing here to have multiple things which are being generated. But for now, if channel equals 0, that's the first channel. Then we do this. So this will, as said, this will need to be improved to do. Yeah, the break doesn't need to be here. Okay. Oh, let's for simplicity now go like with else. Yeah, but we are really running out of time, so we will not be finishing this today. I think we will in the next lecture add here something to our plugin so that it can handle multiple channels, as many as we specify to it. And then what we will also add is of course the missing things here in plugin, set parameter and get parameter. But you know, I think we will just add a hack here, q so that we can actually generate some homework out of this. We just ignore the whole code here. We just set this param, and here we will just return param. So so instead of actually saving the parameters on the plugin and being able to do something with it, what we are doing here instead is we are just saving the parameters on the wrapper object inside our own main application. Thus, calling set parameter and get parameter will, from the viewpoint of the application, actually work, even though what are we missing? Demo plugin. Demo plugin. Abstract plugin set param. My endings that we have. Set and get. Weird. We have defined them. Let's make it build it again. Maybe just. Nope. Does this know what this is? My variant. This is this thing. Abstract object void release. Yeah, that is correct. Param. Constant, non-constant override. That looks correct as well. Interface is defined in interface. This one is const. This one is const. So this thing wants to invoke something else, and that which is not defined. This is so weird. We have an unexpected problem. And this is as a pointer, so this should be fine. It complicates, of course, things since I wanted to schedule the homework, and if this doesn't work, then it's annoying. Do we have more than one demo plugin? Maybe somewhere in another file. Demo plugin. We have a demo plugin here. Set parameter. This one. But this looks correct here. But it's definitely no DLL internally. Abstract plugin. Did we forgot the is equals 0 something? Interface. Yes, we did. Yeah. Good. So this works. So now to the homework. Let's go to data panel. Homework from the 20th. 11. Maybe that's not the right place. We have we don't have a double click handler. Okay, that will need. Did we add that somewhere else already? Here maybe. Okay. So let's quickly edit. We are at our time limit, but since we started late today, we should just add this quickly. So we want here a protected somewhere slot void on plugin double click, and here plugin double click. So the idea is that we want to be able to change the parameters later on by double clicking a plugin. So load the coordinates from the so you just modify the existing window such that it has a second constructor. I could add this as a hint. And then it will create the UI slightly differently, so you could split the current constructor into two functions. And when it does that, then you can call it and create your UI for both cases, for both use cases, and then set it up such that you can load the values to the existing controls and then save them back. So I don't think this is too complicated, but we shall quickly add here the the tree here. So on plugin, double click, item, double clicked. So we have connected here quickly check this that this works. So you get a notification from the tree each time something is double clicked, and voila. So here you get Qt widget items, then pay item is equals current item. Actually, this might even pass us the thing, but you can just go with current item, and then of course check it's an channel or a item for channels there will be a matter to do. And for plugins it just goes directly. You can, for example, do this test. Do we know whether it is there no stop level item? I don't want this to become complicated for a minor reason. Then let's see, for the clicked we just get the item and the column, so we don't really get the information where it is. So we could we should encode the data. So here we are encoding the data by adding the ID, which is generated from the address. And here we are setting the ID just as being the channel number. Okay, so what we can do is we can just save a negative value, and the way addressing on Windows works is that for addresses in the user space you should not get a negative value. Never. There are reserved for kernel address space. So if you see a negative 64-bit value as an ID, so this will make just an int, not an int. So if you see a negative value, then you know that something is fishy. So here we just data name, comma Qt user role to int too long int 64 int is equals this, and if this is less than 0 is valid. If it's less equals 0, because 0 again would, for example, not be a valid address, then we just for now bug out, because we clicked on a channel and not on a plugin. So that's said the homework. We will simply have to open the window again. How to open the window we already demonstrated here with the mechanism to add plugins. Just you choose another entry point which will populate other data, and then if the user presses OK, you just apply set name and set parameters on the plugin instead of adding the plugin and recreating one. So I think this is easy enough. It will give you some opportunity to play around with the UI components in the existing add plugin Wende. The name now sounds not ideal. We should just have called it plugin Wende or something like that, but well, we will stick with the name. And I think it's time to end, since we are running at 2 hours 30. That's already a bit too long. So if you have any questions, you can email them, and yeah, we will see each other next week. Have a nice weekend. Bye bye.